Hello my Radiant Scholars, welcome to your first lesson. Today we're going to be learning about the product rule for counting. Now what is that? The product rule for counting is the way to find the total number of outcomes for a certain number of events, so 2 or more. Now it's really quite simple because all you have to do is just multiply the number of total possible inputs to get the total number of outputs. We'll go through some questions because there's more to learn about it, but it's not too difficult, and this is why I chose it as the first lesson for you to learn. I'll write an example first to show you how it works. Let's say that there's 4 ways for you to eat breakfast, alright? So 4 breakfast, let's just write that. Then we have 3 lunches and 2 dinners. So if I want to find out how many possible ways I can eat throughout the day, I just multiply 4 by 3 by 2, which is 24. So it isn't that difficult. Now I've prepared some questions from past papers, and here's the first one that I want us to try. So it tells us there's 5 starters, 12 mains, and X desserts, so we need to find out how many desserts there are. And it says that there's 420 different ways to choose them. Now, using what we've learnt, we can just say that 5 times 12 times x is equal to 420. So all you have to do is just divide 420 by 5 and then divide it by 12, which is equal to 7. So there must be 7 desserts. Now if I just put that into my calculator, 5 times 12 times 7, you get 420. Alright, 2 marks. Okay, next one. Okay, so in this question, there's 5 starters, 8 mains, and some number of desserts. So Jack thinks that there are 240 ways he can choose them. Now it's really quite simple. We can just divide 240 by 5 and then by 8 in order to find the number of desserts, like the first question we just answered. That's really quite ugly, but I don't really care. We've got 6 desserts, so 5 times 8 times 6 is indeed equal to 240. So yes, Jack is correct. Now, the reason he might not be correct is if he said that there's 250 ways that he can choose them. Because if we divide 250 by 5 and then by 8, we get a decimal. And, well, you can't have a decimal number of desserts. So there must be a whole number of desserts. In this question, there are 16 hockey teams, and each team played 2 matches against each of the others. So what you want to do is do 16 times 15, because, well, the teams are playing against the other teams, and a team can't play against itself. So 16 minus 1 is equal to 15. But it says that they played 2 matches against each other, so we should multiply this by 2. But actually, we need to divide by 2, because it says that each team played 2 matches against each of the other teams. However, if we just leave it like this, what we're saying is that Team 1 played against Team 2, Team 1 played against Team 3, and so forth. But that also means Team 2 also played against Team 1, and so forth. And we can see that these are equal. Now we only want them to play 2 matches against each other, so you need to divide by 2. So there are 240 ways to do it. Easy. Okay, so in this question we've been shown a lock with 3 numbers and 5 possible digits for each of them. Now we need to find out the possible number of passwords that can be set for the lock. Now this is simple, because we have 3 separate numbers and each of them have 5. So all we have to do is do 5 times 5 times 5. Now the reason we don't minus by 1 from each of them is because there are just 5 options for each of the 3 options, because there just are. There's 1, 2, 3, 4, and 5, but not like Teams one, where they can't play against themselves. Now the next question asks, how many of the possible 3-digit numbers have 3 different digits? And now this is where we use our -1 strategy, because in the first number there's 5 possible numbers, 1, 2, 3, and 4, and 5. But in the next one, we want to have a different digit. So we can just remove one of them, let's say 5. So we got 1, 2, 3, and 4. And then the last one, we'll remove 1 again. So you'll see that we have 5 options, then 4 options, and then 3 options. So all you do is 5 times 4 times 3, which is equal to 60. Easy, easy. So this is a question that's a little bit more complex, but it's not too difficult if you break it down. So again, it's a passcode question. Let's just break down the question from top to bottom. So there's 4 digits on the passcode. Each digit is a number from 1 to 9. You can use each number more than once, so I'm assuming we probably don't have to -1. And then these 4 statements tell us what each digit can be. So from numbers 1 to 9, the cube numbers, we've got 1, 2 times 2 times 2 is 8. That's all we have. Then the second digit is a prime number from 1 to 9. So we've got 2, 3, 5, and 7. Third digit is greater than 6. Note that it's greater than 6 and not equal to 6. So we've got 7, 8, and 9. Then the fourth digit is odd. So we've got 1, 3, 5, 7, and 9. Okay, so Amber is going to try to guess Zia's passcode. And we have to work out the probability that she guesses it on the first attempt. Now this is quite simple. All we have to do is to work out how many possible outputs there are, which is the product rule of counting, what this entire video is about, of course. So we'll see that we have 2 options for the first one, 4 options for the second, 3 for the third, and 5 for the fourth. So we just do 2 times 4 times 3 times 5, and we get 120. So you can just say probability is 1 in 120, because there's 120 different combinations for this passcode. Well, that's all for today. Actually, I've finished all the questions I've prepared for this lesson. You should definitely try your own go at some of these questions. If you have any questions, make sure to ask them down in the comment section below, or you can join the Discord for any further help. Thank you, and see you in the next lesson.